Hello everyone, my name is Siddhant Kannan, USN 1VE 22CS 151. I am studying in third semester of CSC branch, Chanakya section, and today I will be talking about introduction to data structures, primarily about stacks. Introduction to data structures. Data structures are fundamental in computer science, organizing and storing data efficiently. They include arrays, linked lists, stacks, and queues, each with unique functionalities and use cases. By understanding data structures, developers can optimize growth algorithms and create more effective solutions for various computational problems. What is a stack? Here's a basic definition of what a stack is. A stack is a linear data structure that follows the last in, first out, or the LIFO principle. There are two main operations for stacks. There is push, which adds an element on top of the stack, and pop, which removes the top element. Where are stacks used? Stacks are commonly used in function calls, expression evaluation, and undo functionalities in software applications. The LIFO principle. Last in, first out. In a stack, the last element added is the first one to be removed. Stack behavior. Elements are accessed in reverse order of their addition. Real life analogy. Like a stack of plates, the last one put on top is the first one to be taken off. Basic operations on a stack. The push operation, the process of adding an element to the top of the stack. The pop operation, removing the top element from the stack. The peek operation, viewing the top element without removing it from the stack. Implementation of a stack using an array. So, what is an array based stack? An array based stack uses a fixed size array to store the elements of the stack. It employs the last in, first out principle, where insertion and deletion occurs only on one end of the array. Each operation, such as the push and pop, modifies the top element of the stack using array indexing. Here are the pros and cons of array based stacks. The pros: it has simple implementation and efficient access. The cons: limited size, potential for overflow or underflow. Implementation of a stack using a linked list. Dynamic memory allocation. Unlike arrays, linked lists allow for dynamic memory allocation, making them more flexible in memory managing space. Easy to insert and delete. Linked lists provide efficient insertion and deletion operations, which is crucial for implementing stack operations like push and pop. Complexity considerations. While linked list implementation allows for flexibility, it may introduce additional overhead due to memory management and pointer manipulation. Here are some of the statuses that are found in stacks: overflow and underflow. So, what is overflow? Overflow is a state of a stack which occurs when we try to push an element onto a full stack, causing it to exceed its capacity. The underflow state happens when we try to pop an element from an empty stack, leading to a shortage of elements. The time and space complexity of a stack operation. The time and space complexity of stack operations is crucial for evaluating the efficiency of the algorithms. In a stack, both push and pop operations have a time complexity of 1 of 0, meaning they take constant time to execute. Similarly, the space complexity for these operations is also 1 of 0, indicating that the space needed does not scale with the size of the stack. Real world applications of stacks. Browser history. Web browsers use stack to track websites visited. The undo functionality. Software applications use stacks for undo operations, most commonly known as Control Z. Call stack. Programming languages utilize stacks for function calls. Book pile. Stacks represent physical piles of books or documents or whatever data. So, finally, we come to a conclusion and the summary of this presentation. A stack is a fundamental data structure, a linear data structure, providing a simple yet powerful way to manage data. From its LIFO principle to real world applications, stacks play a crucial role in computer science and everyday life. Understanding their basic operations and complexities is essential for every programmer. We have now come to the end of this presentation. I hope this presentation has helped you in learning more about stacks. Thank you.